Assalamualaikum. I choose an experiment related to second law of thermodynamics, which is balloon in candle flame. For introduction, total entropy never decreases over time for an isolated system. Isolated system is a system in which energy or matter cannot enter or leave the system. And this experiment also to study about heat transfer related to entropy over time. Also can be expressed as ds equals to dq over t. This formula shows that difference of entropy directly proportional to difference of heat transfer, but inversely proportional to time. Next, we go to objective. We have three objectives. First is to determine relation between size and rate of heat transfer. Second, to determine relation between rate of heat transfer and rate of entropy. And last, to determine relation between rate of heat transfer and time taken to balloon burst. Then, we go to variables. For manipulated variables, we have one manipulated variables, which is size of balloon. And for dependent variables, we also have one dependent variable, which is time taken to balloon burst. And last, constant variable, which is type of balloon and distance between balloon and candle.
The next part of this experiment is hypothesis. Based on the variables stated before, there are two hypotheses. First, the greater the size of the balloon, the greater the rate of heat transfer. Next, the greater the rate of heat transfer, the lesser the time taken for the balloon to burst.
Hi, my name is Valerie Mimin, and right now I'm going to show you on the experiment of balloon with a candle flame. So what we need is a stopwatch, a candle, just a small candle, a lighter, ruler, and also lots of balloons. So I've measured all the balloon with 6 centimeter diameter, which is this one, 6 centimeter, and then 9 centimeter, 12, 15, and last but not least 18 centimeter. I'm going to wear a glove. If you don't have one, it's okay. You don't need to wear one. So we'll start the stopwatch once it reaches near the flame. Right now, we're going to start right now. Okay, it took 5 seconds. Next would be the 9 centimeter. We'll do exactly the same as the 6 centimeter just now. So it increases, the time increases. So next, this one is the 12 centimeter diameter of balloon. We'll do exactly the same as before. It's 5. So right now we'll do the 15 centimeter diameter of a balloon. Hmm, 6 seconds. So the 18 centimeter. Here we go, last one. 6 seconds. So all of them are the same. I mean, it's nearly the same. Like for the 6 centimeter, just now it took 5 seconds to pop. And then the 9, it took 6, 12, it took 5, 15, it took 6, and then the 18 last, it took 6. So we'll wait for the next member to explain this.
The next part of this experiment is discussion. Since this experiment is related to the second law of thermodynamics, we relate it with the rate of heat transfer. According to the second law of thermodynamics, heat energy has quality and quantity. For the second part, heat energy has quantity, meaning heat energy flow from high quality region to low quality region. This can be applied to the definition of heat transfer. In this experiment, heat transfer from the flame of a candle to the air inside of the balloon. To further relate this experiment, ideal gas law is introduced. The air inside of the balloon is assumed to be ideal gas. When the temperature increases, the pressure increases, and that explains the burst of the balloon. Theoretically, the time taken for the balloon to burst decreases as the size of the balloon increases. This is what we predicted at the beginning of the experiment. However, in this experiment, the time taken for the balloon to burst remained constant at 5 to 6 seconds. This result is not as what we expected at the beginning of the experiment. There could be a lot of factors affecting this error, such as the balloon thickness. The balloon thickness is not taken account before the experiment. It could be too thick for heat transfer. Next is there could be errors made by the student. The time taken for the balloon to burst could be mistakenly recorded. The next factors affecting the result is this experiment is carried out during recovery movement control order, which is known as RMCO, since we are in the midst of pandemic. So students are unable to carry out a proper experiment in the lab with proper equipment. Next, another factor affecting is the air in the balloon. Normally, balloon is filled with gas lighter than the air, such as helium. However, in this experiment, students can only provide air by blowing the balloon. It is known in the exhaled air contain most abundant of carbon dioxide, which is known to be heavier than the atmosphere air. So, what can we do to improve this experiment? There are a few ways to improve this experiment. This experiment can be improved by carrying out the experiment in a proper lab, so we can have a proper safety measure with proper equipment, proper attire. This can ensure both safety aspect for the student and the accuracy of the result. Lastly, this experiment can be improved by conducting the experiment in a closed space to keep the flame stable so that the rate of heat transfer is not affected by the movement of air. So, what can we get from this experiment? The conclusion is the relation between size of the balloon and the rate of heat transfer is obtained, which is directly proportional. As the size of the balloon increases, the rate of heat transfer also increases, as in theory. However, due to this unavoidable circumstance, the desired result is unable to be obtained. This experiment can be improved by working out more on the part of the technical aspect of this experiment. Hence, this experiment proves the second law of thermodynamics. That's all from us. Thank you.
Missing someone. Missing someone. Missing someone. Love with